Look at this. We cut open a PCB to inspect what normally stays hidden. This tiny cross-section reveals whether a PCB will survive or fail. Today, we're taking you inside the AIVON factory to show you exactly how PCB cross-section analysis, also called microsectioning, is performed. PCB cross-section analysis is a destructive testing method used to evaluate the internal structural quality of printed circuit boards. It reveals internal structures such as copper plating thickness, hole wall quality, and layer alignment, as well as hidden defects like voids, cracks, resin smear, and delamination. This process is critical for quality control, failure analysis, and ensuring the PCB meets IPC quality requirements. In high-reliability industries like automotive, medical, aerospace, and telecommunications, it's not optional, it's essential. Here's how it's done step by step. First, we carefully cut a test coupon or target section from the production panel using a precision saw. The sample must capture the exact features we want to inspect, usually plated through holes. Next, the sample is placed into a mold and encapsulated with epoxy resin. This mounting process provides solid support for later grinding. Once cured, we begin grinding the sample using progressively finer abrasives. We grind carefully until we reach the center of the hole or the exact plane we need to examine. Once polishing is complete, the sample is examined under an optical microscope. Here, we measure the copper thickness inside the plated through hole to verify whether it meets IPC requirements. Even tiny defects at this scale can lead to electrical failure, thermal stress damage, or long-term reliability issues. On the left is a high-quality microsection, uniform copper plating, clean hole walls, and accurate layer registration. On the right is a failure case. Notice the thin copper area and the void inside the plating layer. Defects like these can weaken electrical connections and eventually lead to intermittent failure in the field. Microsection analysis allows engineers to fine-tune the manufacturing process and prevent costly field failures. In PCB manufacturing, reliability starts long before the product is assembled. It starts here, under the microscope.